Dependent events. Let's look at what is a dependent event. In the world, when we talk about dependent, we say our children are dependent of their parents, and a baby is dependent of either his mother or his father. So dependent pretty much represents relying on something or someone. So in probability, when the first event affects the possible outcomes or occurrence of the second probability or the second event, the event is called a dependent event. Now, we understand that whenever a child cries, a mother or father feeds them. Whenever a teenager needs money for just going out to the movies, he relies on his parents. So kids are perfect examples of dependent. Well, in the probability, they're fairly alike. The reason we know that the event that we're encountering is dependent is due to the fact of key phrases like will not replace, not replacing, removing are all example dependent events. Let's look at the bottom picture. Probability, and we have a deck of cards. A deck of playing cards, which a deck of playing cards has 52 cards. The probability of drawing at one king out of a deck of cards, or the king of spades out of a deck of cards, are different. So, let's find out the probability of playing some cards. Dependent events. Earlier we seen a picture with a hand and a deck of cards. This word problem is fairly alike. A card is chosen at random from a standard deck of 52 playing cards. Without replacing it, a second card is chosen. What is the probability that the first card chosen is a queen and the second card chosen is a jack? Well, first of all, we're going to highlight and underline important key factors. For example, without replacing tells me it's dependent, and we're looking at the first time we draw choosing a queen and the second time we draw choosing a jack. So, first time we look at just the cards with queens on them. These are the cards with queens. There is 1, 2, 3, 4. There is 4 queens. So the probability of getting a queen the first time is 4 out of 52 playing cards. Now, after that, we need to understand and go right back to our illustration that the first time they decided to draw a queen. So they took one of these queens out because they will not replace the first card that they draw. So I'm just going to randomly pick one of the queens and I'm going to place a big X over it. So then, what is the possibility, based on what I have, of choosing a jack? Well, there is 4 jacks out of, now we did not replace the first card, so now there is 51 cards instead of 52, which 4 times 4 is 16, And 52 times 51 is 2,652, which can be reduced if you divide the top by 4 and the bottom by 4. It will give you an answer of 4 over 663, which is your final answer. And this is an example of dependent probability.